From nukes to gravity tractors, how well prepared is Earth for an impending asteroid strike? Well, we all know the answer to that. Last week we had an asteroid preparedness protecting Earth from the impact of asteroids or celestial bodies. And this happens every 2 years by international space agencies and officials, government officials, and they failed yet again to stop an asteroid. Now, this is on Zero Hedge, Tyler Durden. NASA launches an asteroid strike simulation this week, but what would happen if a devastating asteroid was coming our way? RT asks an expert about the tools available and how long it would be until we are finally prepared. While hundreds of small asteroids and meteorites have hit Earth, big objects like a 55-foot one that exploded over Chelyabinsk, Russia in 2013, only occurred around twice a century, they say, and larger dinosaur-destroying ones are even less common. But NASA warns that given the current incompleteness of the NEO, that's the Near-Earth Object Catalogs, an unpredicted impact could occur at any time. It's because it's physically impossible for them to catch everything, especially the ones coming from behind the sun, because from the sun's glare, they can't even see them coming into us, as what happened with the Chelyabinsk over Russia. At the start of 2019, NASA reported there were 19,000 known near-Earth asteroids with an average of 30 new ones found each week. We're talking about the big ones, about 460 feet. The U.S. government had asked NASA to try and locate at least 90% of the big ones. What about the little ones that are less than 460 feet in diameter? Now, according to Detlef Koschny, a co-manager at the Space Situation Awareness, SSA NEO segment of the European Space Agency, he told RT that it's not the large NEOs that we need to worry about, though, but the smaller ones, as scientists are only aware of 1% or less of them, and they could still damage a city or a whole region. Ideally, scientists hope to have several years warning of an approaching NEO or of 100 meters or more, that's about 300 feet in diameter. But when it comes to smaller ones, it's more difficult to see them early on, he says. Offensive defense, anything larger than 50 meters, which is about 150 across, we would try to deflect. This is what Koschny said, pointing to NASA's 2022 Double Asteroid Redirect Test, which is DART for short. It aims to intercept an asteroid's moonlet when it gets within 11 million kilometers of Earth. The hope is that it can change the speed of that asteroid by kinetic impact. He says, unfortunately, deflection methods require a few years of preparation, and the correct spacecraft would need to be built. Well, why don't you just use DEW on it, laser it to pieces while it's really far away from us? I don't know, I'm just, talking off the top of my head here. Now, the White House Office of Science and Technology Policy released a 2018 report outlining a 10-year plan to prevent asteroids from hitting Earth. It involves creating modeling tools and simulations to characterize risks, planning reconnaissance missions, and developing technologies for fast response missions to deflect or disrupt hazardous NEOs. In Europe, NEO Shield carries out research and development to reduce the risk of an NEO deflection mission failing and has outlined several methods to prevent NEO causing damage. One proposal is a gravity tractor, which involves positioning a heavy satellite close to an asteroid, which then pulls the asteroid away. It's a good method, Koschny said, as scientists already know they can get satellites close to asteroids, but this kind of mission takes a long time, around 10 years. Well, let's remember, we don't have 10 years because we have the Apophis asteroid coming in at us in 10 years exactly, April 13th, 2029. And in 2035, we have the Bennu coming at us, asteroid comet planet Bennu. Now, so we have a couple of huge bodies coming towards Earth. Now, meanwhile, using an ion engine to push the asteroid away has also been tabled, takes several years, and there are still some technical issues to understand, he said. At the most extreme end of the intervention scale is a nuclear explosion, in other words, to attack it with a nuclear explosion, in which scientists would detonate a warhead right beside an asteroid so that the space rock's surface is superheated and vaporized. That's assuming that it's made of ice. Comets are not made of ice, though. Asteroids maybe, but not comets. They're rocks. So you can't do that with a comet. Now, this vapor pressure then acts like a rocket fuel moving the asteroid and is the most effective method, Cautioney said. However, it clearly has its disadvantages. Quote, politically, it's not accepted because if the risk of radioactive contamination that could occur if the launcher failed or something went wrong. Standard explosives could also be used to shift the asteroid from its doom-bearing path, its trajectory towards Earth, that is, and another method involves embedding an explosive inside an asteroid like the Hollywood movie Armageddon and then blowing that up. Asked how long it would be before we are fully prepared to prevent any asteroid from hitting Earth, Cautioney said, if we continue taking the subject seriously, we'll be there in 10 to 20 years for objects up to a few hundred meters in size. So let's just hope no surprise asteroids come our way before then. Well, they're not surprised, but we know of the two of them, the huge ones that are coming at us, and it seems that we don't have any way of deflecting them or, changing their trajectory from Earth impact. Here we have the trajectory of the Apophis asteroid, and this is how close it's going to come to us April 13th, 2029. As you can see, it's as close as our satellites are. Now, around close to the poles of the Earth, you have the purple line indicating that that's how the ISS flies. And you can see how close Apophis will be at us. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.